Cool. All right. Yeah, thank you guys so much for joining. This is going to be the first of hopefully many SIG Knative meetings. As a quick introduction, my name is Daniel. I'm an Airflow committer, and I'm particularly interested in the Airflow Kubernetes story. And yeah, so let me share my screen and we can go into what our notes are for today. And of course, if anyone has any questions or any comments along the way, absolutely please stop me. So let's see. 1 second. All right, cool. So yeah, so first of all, welcome everybody to the first SIG Knative meeting. And the first thing I kind of want to go over is kind of, since this is the first one, just where we are, what we have so far, and kind of see where we can start bringing more of the community in on this project and where people would be interested in what features people would want to see. So we'll start out with a document that some of you have already seen, which is kind of an overview of the current Kubernetes Knative architecture. So essentially, the problem we're trying to solve is that there's two kind of design issues in terms of using the Kubernetes executor as a primary executor, which is if you're trying to have things with short SLAs, starting a new pod for every task can get very expensive. And if you are, when it comes to scaling, having a brand new Airflow instance for every single task you're launching can get pretty expensive. So what we wanted to do was we wanted to kind of simplify that using Knative, which is a functions as a service library. So essentially you can define any server that takes HTTP requests, and Kubernetes will auto scale that server. And as far as where we are in terms of like progress, we have, I actually, unfortunately it's not, I changed a few things. It's not demoable at the moment, but there is a working version of this, but it's still a very early one. So there's still a lot of room for design changes and for feedback. One feature that I think would be really cool here, and thank you to James Michael, I see you're on the call, is Knative-based queuing. And that's something we've actually been working very hard towards. And the idea here is you can essentially, you can define as many Knative services as you want, and they don't take up any space unless you're using them. So we can create something similar to celery queues, where essentially you could have a high memory Knative queue for, say, like things that involve anything involving a nasty amount of RAM, or with different security settings. And so just any arbitrary number of queues, and you can define those at the task level using the queue feature. In this document, by the way, I also have added in some instructions for how to get started with the local Knative environment. So Kind is a new, a pretty new project, Kubernetes in Docker, and it's fantastic. Unlike Minikube, where you have to start a brand new VM to run this, this will work within your local Docker, and this is what Kubernetes uses for their CI/CD. It's pretty well tested. And it's a lot simpler to use than Minikube. And so then there's also some instructions for, you need Istio, but you only need the gateway aspect. You don't need the entire service mesh / sidecar containers. But we can talk about that later. Let's get to the actual, by the way, any questions so far? Cool. So yeah, let's talk a bit about the architecture. So essentially, the most important part is this right here. This is the Airflow worker. What we've essentially been able to do is kind of rip out the task running capabilities of Airflow from the executor and turn it into a responsive HTTP server. I actually have the code for that right over here. So this is what the code would look like for the task runner. So essentially, we're using the AIO HTTP library, which is a library that's pretty scalable, it's pretty lightweight, it's not a full Flask deployment, and you can define these asynchronous functions so you can run multiple at the same time. And what we do is we essentially run a task, and we are, so essentially we're able to run a task using the run raw function, so it's not tied specifically to a heartbeat. And in doing so, we can scale this out as much as you want. So essentially, you have these small workers. We can use Gunicorn to have completely isolated processes for every single request that gets received. And so, like, let's say we have 10 Gunicorn processes per worker, and you launch 100 tasks. Now you can do 100 tasks in just 10 pods instead of doing it in 100 pods with the Kubernetes executor. Any questions about that part? Okay. So, and as far as the whole queuing architecture, essentially, this is what an Airflow queue would, this is what a queue would look like. So a queue would just be a basic Knative service. So what a Knative service is it's kind of a pod template. And so you define what the pod should look like, what command it should run, what secrets, what volumes, what volume mounts, with the caveat that you can't use persistent volumes in Knative. That was a design decision where the Knative runners don't want people keeping state in Knative. But other than that, there's a lot of flexibility in terms of environment variables, secrets, resources. So you could define different queues for different security levels and also, or like node affinities. Let's see. I like the idea that there's a per pod target concurrency. You could have more. Yes, exactly, James. So James just said that because you can basically define the amount of concurrency, you can you can essentially lower the amount of concurrency based on the number, based on the security. But there's also one other thing that has worked out pretty nicely. I'll show you this. So this is the actual Knative executor that we have working right now, the demo version. And one thing that was kind of a nice addition is, let's see, where is it? Yeah, so essentially, it's actually not that hard to put an executor inside of another executor. So, because one thing to keep in mind in terms of limitations right now is Knative gets a little bit funky if you're trying to do super long running tasks. So we've tested it, I believe, up to an hour so far, and it's been fine. But the guys at the Knative, the people at the Knative team, were kind of warning that, you know, keeping long running HTTP connections for hours on end can be risky, and also having Knative run for too long can delay Kubernetes upgrades. So what we offer is we can basically have a Kubernetes executor inside the Knative executor and then piggyback on the Knative executor heartbeat. So whenever it's running a sync function, if the kube executor has been initialized, you sync it. And when you are actually giving the pod, when you're actually giving the request, if you set the queue to Kubernetes, it'll just launch an isolated pod for you. So for tasks that you need the functionality of the Kubernetes executor, the Kubernetes executor will still be there for you. So yeah, as far as where we are right now, like I said, we have a PR against master. It, for the most part, it works, but there's still open questions in terms of long-running tasks and what features should we add? Are there any features we should take out? And, you know, I want this to be a community effort, because the more people are kind of giving feedback on this, the more resilient this will be, and the more it will meet as many use cases as possible. So that's kind of where we are right now. I definitely want to open it up right now if anyone has any thoughts, any kind of like what you would hope to see from a Knative executor, or if there's any kind of things that you've not been a fan of with the Kubernetes executor that we might be able to solve with this executor. Yeah, just generally want to open up to discussion.
Hey, so this is James. I just unmuted myself. This all looks totally awesome so far. I really like the approach of having a hybrid executor. So being able to launch either on a dedicated pod or use Knative pods. One question I have there is, I saw that the way that you're doing this is that it's a Knative executor inheriting from base that sort of like sub-instantiates another executor. I was curious if you thought of ways to just have Airflow support multiple executors in general and understand how to differentially dispatch certain tasks to certain executors.
So I actually did look into that. That was originally what I was thinking. The problem there is that it involved a lot of pretty nasty core changes to support multiple executors. But one thing that's kind of funny is, so actually going back, there's something kind of interesting about the paradigm shift with how the Knative executor works, which is that this is the first executor that essentially just treats, like completely isolates task execution from scheduling. So if you look here, essentially the Knative executor is a dumb HTTP client. All it's doing when it executes is it makes an asynchronous request using async IO, and it waits for a response, and it doesn't know anything else. And so one thing that's kind of interesting is that with this task runner worker, there's no real reason why we can't add, say, like a run this task in Celery function, where if you have the infrastructure and you have the wires connected, you could add a run in Celery or a run in Kubernetes to this server, and then it's just a matter of changing the parameters or changing the path.
Yeah. So I guess a more concrete version of like why I'd be interested in this functionality is, so we use the Celery executor right now, but about half of our workloads currently run on Kubernetes. And with a mix of an in-house operator and the core Kubernetes operator. And that's actually going to be pretty painful to cut over everything to like a new version of an executor in one go. So being able to gradually migrate it would be great. And I feel like a lot of people may be in the same boat where you have a partially containerized workflow because that's the way a lot of people launch things on Airflow right now. And then switching it over to run in Knative, you don't necessarily want the Knative tasks then launching pods themselves.
It is a good point as far as like maybe not having the Knative task launching pods, because then if the Knative task dies and what's monitoring the pod, that can get a little funky. As far as having more than one executor at a time, Ash or Yarrick or Caxel, do you guys have any thoughts on that?
Technically possible if someone writes the code. I mean, there's no reason not to. There's no like fundamental reason Airflow couldn't support it, but it doesn't right now.
Yeah. So I guess what I would say here is I would be willing to help on an effort for that, but it would have to be clear that there was appetite for that other than me.
I guess that depends on how big a change it ends up being. If it's a small change, sure, it's great. But if it's a big cross-cutting change, which I don't think it should be, then I'd say it's probably not worth it from an Airflow project point of view. If you have a look, if you do a bit of investigation and kind of open a Jira, ping us on the list or whatever, and go, I've had a look, it is a tiny change, here you go, or something like that, then yeah.
Yeah, I remember when I was looking into that, it was less of a like core change in Airflow functionality, more just like an annoying change. But I don't see why you couldn't make like a super executor class and then just kind of based on like you could have like an executor field in the task, or like you could have like an executor field, and based on that, just have a super executor holding multiple, kind of the same way that the Knative executor has a Kubernetes executor inside of it. Really, the only things that matter, like when you have an executor running, is so I mean, there was that one issue. Ash, I remember that one with the bug in the local executor and the Kubernetes executor, where essentially, because of how the because of how multiprocessing works, if you launch more than one, then suddenly it was creating deadlocks.
I think that was one of the same thing and how we were creating it more than anything else.
Well, so in that case, it was because we were creating one, in the base executor, we were creating one executor as like a parameter default and then creating another one further down. But we just have to make sure that like we're not running into those race conditions with the multiprocessing managers.
Yeah.
But that were both the same executors, right?
Does that would that change it if it's a different executor? Because I think multiprocessing creates like an internal server or something. So like I don't know if it's like
it does, yeah.
Yeah.
Don't know, but like so it's like someone needs to do some investigation. Yes, it would be a great feature, James. But it kind of it depends on how big a change it has to be to the scheduler.
Yeah, but James, I am glad to like sit down and like kind of hack at that for a couple hours with you at some point if that's something of interest to you.
Yeah, I would be pretty happy to see like could I get that in as the part of 2.0 changes, because from our perspective we do want to use this executor whenever it gets in, but it definitely wouldn't be until after 2.0 for us.
Of course. Yeah, so this executor is definitely 2.0. Like this for the least of which reason being that async IO does not work well or at all in Python 2.7. At all, yeah. I forgot which of the two it was. But yeah, so for that reason at least, among many others, this would be a 2.0 change.
I had to duck away for a bit, but I'm not sure if it was brought up or not, but one of the things that this executor currently does is it somewhat fundamentally changes the process model Airflow executes tasks under. Right?
Well, I'm not sure what I follow.
Currently, maybe it's not the execution, but it's the DAG parsing. Because if the same unicorn worker gets two tasks in a row for the same DAG, it will use the same definition, right? It won't reparse the DAG parsing.
Yeah, so me, Ash, and Ash Caxel and I have been doing a lot of research recently into kind of like what some of the slowdowns in the scheduler are. And one of the major slowdowns is just having to reparse a whole DAG every single time you run a task.
On that front, I've done a bit more. It's not actually the reparsing of the DAG that's a slow bit. It's the reloading of Airflow modules and config that's slower. So we may be able to change that if we want to remove that. Yeah. For everyone else, kind of, I've been doing a whole load of digging and profiling of the scheduler and the local executors. And it turns out a lot of the slowdown of just like general Airflow feels slow to run tasks is because of when you pass off a task to an executor, it does a fork and exec. So it starts up a whole new Python interpreter, which then has to reload Airflow to then run a task runner, which then runs a second one. So it runs the task monitor. That then starts a second whole new Python interpreter that does all that all over again to then run the actual task. Rather than forking so that Airflow, all of Python and all the Airflow modules and all its dependencies are already loaded. That gets something crazy like a 7 to 20 times speed up depending on your hardware if we fix that. So I've got a PR coming for that soon. But yeah, just the Knative Executor as it currently stands changes the DAG parsing semantics. We may need to look at that.
Yeah, I mean, it's part of it. What I would consider a larger effort of, I'm very much pushing towards separating any form of task execution from the scheduling. I think scheduling should be its own isolated thing, so that way, if we want to rebuild it from scratch or if we want to clean it up significantly, it doesn't affect anything when it comes to the task running.
Yeah, so, I agree. Currently, the scheduler does more than what it should do.
It's more than a scheduler.
Yeah, it's a supervisor.
Here's a question then. Let's say that I've just deployed a new DAG version and it hits the scheduler. So now I need to like submit to my Knative queue and have it actually use the new code. How does that work? Does it like make a new Knative queue? Does it like kill the existing workers and wait for new ones to come up, or how does that work?
So it doesn't. So I actually asked the Knative community about that, and it works. It works exactly how we would hope it would work, which is if you upgrade the Docker image, which by the way would probably be the main way of doing this, since Knative doesn't allow for persistent volumes. So if you update the Docker image, what will end up happening is the current tasks will continue running. It won't automatically kill the pods, but any new requests that come in will be launched as new pods. So you don't have to change the service name, and the currently running tasks will not be killed, but Knative is smart enough to know that, hey, this pod is actually an old version of what we're trying to do.
Great. Now, do you anticipate this being like you pre-provide Docker images, or are you expecting users to build their own?
So, I mean, we're Yarek, how close are we to releasing an official Airflow Docker image?
I would say weeks rather than months. So it's coming close. Can you hear me, by the way?
Yes, we can.
Yes.
Okay. So yes, I'm working on this new production image. And we'll have the base image. And my question connected to that would like how do we bake in the DAGs that we are executing within the image in Knative Executor? Is it something like is the image additionally built before Knative Executor starts the pod, or how do we?
Yeah, that's what kind of how I was assuming is like basically once we release this production Airflow image that's been kind of battle tested and ready to go. Essentially, that could be a very easy base image. You can bake in your DAGs. When we were first making the Kubernetes executor, we offered the PV and Git sync options because we were afraid that baking in images would become really painful, and like we thought that like large amounts of DAGs would cause problems, and turns out that you can bake in a lot of DAGs, and I mean it's just Docker. Like it worked out really nicely.
Would that be this way? Just my question. So every installation will have their own, let's say, Docker image, which is like the base Docker image plus all the DAGs that it can execute.
Yeah.
And then we will from there, rather than, because I could imagine two options. Like one option would be that scheduler will actually prepare a new image based on the base image and add the DAGs that should be executed when it's executing one DAG, or it should be like pre-baked and prepared before you actually start the executor. So the advantage of the first solution is that if we have a new version of DAG, we will not have to prepare and push a new image. It will happen automatically by scheduler. Basically.
That sounds like a job to CI for me. Also, doing a Docker build and having push credentials to a registry if you're running it in a Kubernetes cluster is probably not something most people will have. So one, you can't access the Docker socket easily. And two, if you're on any kind of registry, your scheduler is unlikely to have permissions to push images.
So I see a potential problem here on the CI side, though I do agree that CI is the right way to build these images. So let's say that I push some new DAG code, and that builds this new image for me with this new DAG code. But then the scheduler also needs to know what image I'm using. And if I have a Git-based config for the scheduler, the question is, if I'm not directly using that image to run the scheduler, how does the scheduler know which image, unless I send in an additional commit, which is going to bump the image version again? I don't know if that made sense.
Well, so the scheduler doesn't need to know anything about the image you're using. The scheduler just needs to point to the Knative service.
Okay, so the scheduler isn't managing the Knative service. It would be CI's expectation to deploy new Knative.
Yeah, so you would like, this would kind of be a case where, you know, I think that Kubernetes is now common enough that, you know, like with the Kubernetes executor, we had a very strong aversion to any form of YAML, but I think now, like, you know, Kubernetes has been around for years. Like we'll give a couple of basic templates, and it'll be pretty easy to just modify those to whatever queues you want, and then you can just kubectl apply those in your cluster, or however you want to launch those Knative queues.
Yeah, that does sound good to me, but then I wonder, are there going to be any problems with the scheduler, like just submitting to a queue that it doesn't actually know the version of?
So, I mean, there wouldn't be versions here unless you, like, the version, if you want versioning, you can name the queues different things. But like, the way that we're seeing the queues kind of working is like I mean, the URL is usually something like service name dot namespace dot cluster dot local, and so if you update that queue, it'll have the same service name. If you want to have two different versions running at the same time, you can basically copy paste that YAML file, modify the service name, make the modifications, and then relaunch it.
Well, just to give a concrete example, like let's say that I'm deploying the scheduler and I'm deploying Knative at the same time.
Sure.
Right, there's no guarantee which order they're going to land in. So it is possible for the old version of the scheduler to submit a job to Knative after Knative has gotten the new version. So you now have like the old task definition in the scheduler getting sent to a new worker. I don't think that that's like necessarily a blocker, but that seems like a problem that could happen, right?
Yeah, because we now seems that we not only have to synchronize the files to with the scheduler, the files with the scheduler, but we also have to synchronize them to the image that will be executed by Knative service. And so it's like another synchronization for DAGs that is required. So far, we only have to synchronize the DAG in a kind of distributed volume, but now we will have to synchronize both volume for scheduler and the image. But I really think I'm just really thinking that maybe I mean, as you mentioned that there will be no production push capabilities for anyone, but isn't that the case that the Kubernetes itself has the internal image repository that you could push the images to using kind solution, using the Docker solution in general? And wouldn't that be
on GKE? You can't push images anywhere unless you've got permission. There's no like in cluster repository that I'm aware of.
Yeah, people don't run the in-cluster registry on all Kubernetes clusters. We don't use it ourselves.
Yeah, there's also, to me, that like, I mean, I know we're already running arbitrary Python code, but pushing arbitrary Docker images from Airflow is also a little bit scary from a security perspective.
Okay.
Yeah.
So we really want to.
Oh, go ahead.
So we really want to base like the workflow for the users will be that they have to both push the files to the change the image, upload the new DAG file, rebuild the image, push it to the repository, change the definition of the Knative service to use that new image, and put the same DAG files into the folder of scheduler. Is it right?
Well, maybe this is something that we should be clear in the docs, but we're assuming that you'll also bake it into your scheduler image, and when you build one image and use that same image for your scheduler and for your Knative queue. So you don't. So we're not.
So this
I get think.
So it's more changing the distribution of DAG to really base them on images. So both scheduler and Knative Executor simply get a new image. That's actually, I like this idea.
But it's not actually a requirement to run the scheduler in Kubernetes, right? Like it needs to have Kubernetes.
No,
yeah.
No. So Knative is based on Istio, so you can absolutely. Istio has internal and external gateways. So if you want to run it outside of the cluster, you just have to set up that external gateway.
Yeah. So I guess it's not like strictly a blocker that you can get into that kind of like race condition, but it seems like it's possible. And also if you're doing multiple types of deployment, like in our case, we use a periodic git sync on non-Kubernetes, but on Kubernetes, we would use an image push and a YAML manifest push. Right, so now if you're talking multiple deployment strategies, it does increase the odds that you have an out-of-sync scheduler and worker instances periodically. So I feel like that should be at least documented.
Yeah, I mean, there is a bit more there is a bit more complexity in terms of infrastructure because we're adding a layer of infrastructure. But I guess everything's kind of a trade-off. You know, like if you need that high scale, if you need those short-term SLAs, like. But yes, this is something that we should either be trying to minimize in terms of complexity, or at the very minimum, document so that people know what they're getting into.
But one idea as well, because if we actually can constrain ourselves on scheduler to use Docker, not necessarily Kubernetes, but Docker image, and run scheduler from the same image that has the same pre-baked DAGs, then actually scheduler could also add the information about the Docker image version, use SHA of the image it was actually used to schedule things, and that one can be used by the executor. Would that be possible? So that we pass the image of the Docker to use for this particular run, or for this particular run of task. Because that would be ideal, because then you would always have a synchronization between what scheduler sees and what is actually executed by Knative Executor.
I don't think you can do that with Knative, because you just post to a Knative queue, and the queue is defined, you know, it's a Kubernetes resource, and that defines which image to run. So it's kind of I don't think
one Knative service is absolutely tied to a specific Docker image.
Okay.
You could technically have some form of like a monotonically rising number based on what version you're running. But once again, that's something you'd have to manage. You'd have to make sure that every time you're updating your DAG, maybe you're updating some environment variable so you know which version you're running.
Yeah, that's something, but this can be automated fairly easily, I guess.
Yeah, you could do something where each time you deploy to a new Knative queue, and somehow inject that back into your DAG so the scheduler picks up the queue name to match.
Yeah.
Or not,
Yeah.
One other problem we would run into with like locking it to the scheduler is that would break the ability to use more than one Docker image. Like, let's say I want different Python library versions, or I want like Py2 versus Py3, something like that. So it shouldn't be constrained to like a one-to-one mapping like that.
yeah,
It's not.
Is it possible to run several services of Knative or kind of dynamically change them?
I mean, it's possible to have several services, and for like if you want to have separate images, you could technically make those changes and just make sure that the DAGs are the same. So if you want to program that into your CI/CD pipeline, like, yes, one thing you do lose compared to the Kubernetes executor is the simplicity of being able to just have different random Docker images. But yeah, you could totally have separate queues, have separate libraries or versions and stuff, and just as long as the DAGs are the same, it should execute correctly.
What I could see being valuable as like an extension to this, you know, you start with an approach where it's just your expectation that you manage the services. Mm-hmm. But in the future, it could be nice if the scheduler can, you know, make some kind of manifest based on the deployed DAG. So not using the Docker version, but using like some hash function over the set of DAGs that it loads, and then actually manage multiple services for you. So the same idea that you had of like a monotonically increasing number, but that would mean that you have the scheduler aware of a version, which is like some set of DAG hashes. And then those get corresponded to Docker images, which may have a hash of their own, but will probably be a different hash than whatever the scheduler is seeing.
Yes, but I think it's more complex than that, because there is more than just the DAG that goes into actually running it. So you've got all the dependencies and any other Python modules you've got installed. So the hashing starts to become a lot bigger.
Yeah, that's true.
Yeah, but it can be done, actually, I think.
Also, I would like to kind of put a pause on this conversation. Yes, it's a good feature, but it comes into a much wider thing than just Knative, which is how do you make sure that things run concurrently. And this is one of Dan Davidoff, Aeon's kind of points. One of the things I can't remember if it was reason for voting against the serialization PR, but he wants this, and I agree with him. It's a nice feature, but it's a whole separate feature. It's in a big chunk of work in of itself. I think independent of Knative or serialization, it's a how do you get the scheduler to run repeatable tasks for a version kind of and deal with cross upgrade boundaries.
Yeah, that makes sense to me.
So okay, so yeah, I mean, there's a lot of like kind of really good paths we can go down. I guess, and let's see what time. I guess one thing I want to make sure we kind of go over before we do any form of wrap up is, so I know, James, you mentioned you want to do some research into can we have multiple at the same time, multiple executors. I kind of wanted to see like a little bit of like who would be interested in kind of being a bit more active in the effort. If you want to just come to the meetings, that's also just fine. Any advice is fine. Any form of stress testing is awesome. Or if you also want to contribute, we're definitely very happy to have people aboard. Is there any interest in terms of people who want to also join in on this project?
I'm also interested in this having parallel Kubernetes and Knative Executor running. That's something that I think was it was a bit blocker for like managed environments, like services in the cloud, because indeed the long-running HTTP connection is often something that it doesn't work in those environments. So relying only on Knative is not a good idea, because there is this long-running HTTP connection. So I could actually, with you and James, do some kind of work on and trying this multiple Kubernetes and Knative Executor running at the same time.
Yeah, and I think that you know, if it's not too nasty of a change, I think that there is a really nice aspect there of being able to slowly migrate. Like we can make it that you can make the change at a task level or a DAG level, so that some of your DAGs run on Kubernetes Executor, some of your DAGs run on Knative, some of them on Celery Executor. And
maybe we could use even my question, could we use queues for that? So like have a queue dedicated to run on Kubernetes Executor and one on Knative? Because that you mentioned before that there should be like a executor parameter on that of tasks, but maybe we could use queue for that.
Yeah, I
was
was
do by adding a field to the queue.
Sorry,
I didn't quite hear that with the crosstalk.
Yes, we could do it rather than having to add an extra field. We could rather than having to add an extra field onto task instance or onto task, we could add a executor field onto the queue.
yeah, because that sounds like a fairly natural way of doing it.
We already have an executor field on sub-DAG operators, for example.
Haven't we removed that now because it was broken?
Have we?
Maybe, I don't know.
Okay, not sure about that then.
That was the direction that I was leaning as well. I was thinking like, you know, you have your queue entry, which I think queue is a string field, and then like just provide some mapping function somewhere in your config.
Yes, queue is a string field. Oh, I'm thinking pools. There's no queue database object. We could possibly map it onto pool instead.
yeah, I mean, we can like
one of those two.
Let's make like a multi-executor Slack channel, and we can kind of all just asynchronously figure this out, and maybe even set up a separate meeting just for that.
Yep, I'm happy to take part in this and do some testing on that.
Yeah, to me it sounds like a really nice migration tool, and it kind of lowers the barrier to entry for people who want to test out other executors.
Yes, especially if we make it kind of like fully flexible to add, you know, like to have even like five, but migrating from Celery to Kubernetes, for example, is a good idea to have.
Yeah, absolutely.
Cool.
Awesome.
Do we have any actions from this?
Yeah, let me go to the notes. So action items. Here, let me. Quickly share my screen. So, okay, as far as action items go, thing number one, so investigate multiple executors simultaneously. Look into race conditions in Docker image updating.
Yeah.
Anything else?
I think we might try to document the kind of workflows that we imagine for updating, distributing the DAGs. That's connected with this race condition. So like maybe we can, like put that to the community and ask them to comment on like how they see this updating of DAGs to work with them.
Yeah, I think the workflow update is also really useful because like the existing people using the Kubernetes executor, it's my understanding many of them do use the git sync, which sounds like it won't be supported at all now.
And by the way, why don't we support git sync? It doesn't really need persistent volumes, I believe.
That's true, actually, isn't it, Dan? Like, so
Yeah, I'm thinking about that.
Like,
Can
volumes.
we support git sync?
Because that would be the easiest migration path, indeed, right now. Without these pre-baked images.
Work with that because of the caching that we've kind of like only loading the DAG once per worker. So we'd need to change that if we wanted to support it.
Yeah, but I mean, like, if you set like git sync equals true or something, then it just knows to do that.
It's just, there is this git sync Docker image that you can have as a sidecar.
Right. So there would be the complication that it sounds like you're not reparsing the DAG. So if you did do a git sync on like an existing worker, it wouldn't do anything and could actually subtly break things depending on how the DAG is getting loaded.
We would have to
that's currently done. Yes, I think we can change that and only lose a tiny fraction of the speed. Like a tenth of a second kind of thing. So I think that particular bit is not a problem. Not certain on that one, but
yeah, I mean, like we could basically set it that like we'd have some sort of like an rsync type of thing where it's just there's some sidecar that's just continually pinging git or something like that. Like
there is already ready git sync, the Docker image which is used in many places for Kubernetes.
The thing we have to investigate is like, so I know that Knative doesn't allow for persistent volumes, but does it allow for does it allow for local volumes if we wanted to like share between those two things, and B, would having that forever running git loop, would that cause the Knative workers not to shut down?
No, it shouldn't do, because Knative wouldn't see that. Knative only shuts them down based on the requests it sends to them. So it wouldn't see, if the sidecar works, it wouldn't see them as doing anything because it doesn't know what they're doing. It only sees the request, it puts it at the top.
Okay, then yeah, let's look into git sync. Can we share volume amounts between containers? Cool.
If someone wants to dig into things, I'm browsing through the Knative docs. There is a as well as the service resource we've been talking about, there's also a revision, and it says the revision.serving.knative.dev resource is a point-in-time snapshot of the code and configuration for each modification made to the workload. So I'm wondering if maybe that might be an answer for the kind of idempotency thing we were talking about earlier. I don't know. Someone will have to read the docs. I'm just skimming the docs.
What was it called, Ash?
It's a revision. So it's a revision.serving.knative.dev. That's the Kubernetes resource type. I don't know what you can do with it. It exists is all I've seen.
Cool. So yeah, I think this is a good number of action items. If anyone wants to attack these, just attach your name at the end. Otherwise, we can just kind of go through these one by one, and we'll kind of fill in the notes as we do. And when we meet next month, we can talk about what our findings are.
Sounds good.
Awesome. Thank you everyone so much for joining. And yeah, I'm pretty excited about this this new executor.
Thanks, Daniel, for organizing.
Thank you.
Absolutely. See you guys next month.
See you.